In today's video, we're going to be testing this brand new 300 amp hour compact battery from Dr. Prepare. Now, I absolutely love this form factor because it saves on so much space compared to previous batteries I've tested. Now, just to demonstrate the compact form factor, I have two other batteries here on the table. This is a standard 100 amp hour battery. This is a group size 31. Now, you can see that this battery is just a little bit wider and just a little bit taller, but it has 3 times the capacity. Now this one right here, this is a massive 200 amp hour battery. You do see quite a few in this form factor. Now this is interesting because it has a bunch of airspace around the cells. So much that I was able to install a voltmeter, USB ports, and even additional Anderson power pole connections on the inside without even touching the cells. Now you can see why I love this form factor so much. You get a massive amount of capacity in such a small space. Now, the second reason I wanted to review this battery on the channel was the pricing. If you look at their website, at the time of filming this video, it's on sale for $329, and they also provided my viewers with a 10% off discount code, dropping the price slightly under $300, meaning that this is around 7 cents per watt hour. That is one of the most affordable batteries I've ever tested on the channel. But how does it actually stack up to its performance claims? Well, we're going to do a bunch of testing on the battery, and then after all that, we'll do a teardown to see the build quality. Now let's briefly go through the battery specifications, starting with the capacity. It is a 12.8 volt nominal 300 amp hour battery rated for 3,840 watt hours. This almost has 4 kilowatt hours of capacity. The charging voltage is 14.6. The maximum discharging current is 200 amps. The maximum charging current is 100 amps. This does have an advertised low temperature charging protection, and it does support series up to 4 in a 48 volt battery or parallel connections. Now, the battery does come with a detailed user manual and warranty card, and then also you get a bag with these brass terminals for the battery, washers, and plastic covers. Now first, I completed a capacity test on the battery with my DC electronic load. I had it set to a 0.2C rate or 60 amps. By the time the battery had shut off, I pulled a total of 307.9 amp hours or 3,928 watt hours. So we did pull over the full rated capacity of the battery. This result was around 102% of the rated capacity. Now I also tracked the voltage curve during this test just to make sure there wasn't any voltage sag, and you can see that the voltage curve is very flat throughout the entire test, which is good. Now moving on to the next test, I want to see if the battery can handle the maximum discharge current of 200 amps for 15 minutes. Now to test that out, I will be powering up a 2600 watt load on this SunGold Power low frequency inverter. Now this inverter is rated for 4000 watts, so it should handle it with ease. So let's go ahead and get it started, and we'll start the timer. Now it's taking me about a minute to zero in the load here. You can see on my clamp meter we're showing 201.8 amps. I've started the timer, so let's see if it can handle it for 15 minutes. Okay, so it's been going for a little over 15 minutes, and it's still running the 200 amp load, so yes, it can handle 200 amps maximum output without shutting down. Now after the test had finished, I did use my thermal camera to measure the battery terminals. I like to do this to see if the conductors on the inside of the battery are undersized or not. Now I measured 130 degrees, or a little bit under that, and my inverter measured 117 degrees. So these temperatures are pretty close together. I'm guessing they are using decent conductors on the inside of the battery. We'll find that out as we do a teardown later in the video. Now in my next test, I want to see how many amps the BMS will allow before it shuts off the battery. In order to test that out, I'll be using my 1000 amp carbon pile load tester. Now if you remember, the BMS is good for 200 amps continuous, so I'm going to slowly turn up the amperage until the BMS shuts off. So let's see what happens here. 100, 200, 300, 400, 500, 600, 700, 800, and it didn't shut off. So let's go ahead and do this test one more time. I'm going to be a little bit faster just to see if that will trigger the overcurrent protection. So let's go ahead and start it. We're going to go quick. Nope, it does not shut off. Now I want to do one last test with my load tester here. I want to see if we can pull about 350 to 400 amps and if it will actually shut off. So let's go ahead and start this. Turn it up to 350 amps. Let's just see if the BMS shuts off. I'm not going to go longer than 20 seconds on this test. Yep. And it's not shutting off. So those were pretty interesting results. Even though we pulled over 900 amps or 350 amps continuous, the BMS over current protection did not shut off the battery. I am guessing that it still has a high temperature protection built into it, but we'll have to check that during the teardown. If you are going to be using this battery, I would definitely recommend having a DC breaker or fuse installed for overcurrent protection. Now, I asked Dr. Prepare about these results, and they came back saying that there are 2 batches of batteries. The first batch of batteries has a really high overcurrent protection setting on the BMS, and then they've updated that with the newer batch of batteries, which has only a 600 to 800 amp setting. So my battery must be from the first batch. Now, this battery is also advertised to have low temperature charging protection. So in order to test that out, I've had the battery in my Iceco VL60 fridge for over 24 hours, and the internal temperature of the fridge during this test was around 20 degrees Fahrenheit. So with the battery removed from the fridge, I've connected up my adjustable power supply, and you can see that it's not charging. So low temperature charging protection is functional on the battery. Now, just to confirm the battery would start charging as it warmed up, I left it out for over an hour at room temperature, and it did resume charging as normal. Now, before we do a teardown, let's just briefly go over the results of all those tests. Starting with the capacity, we got 102% of the advertised capacity, so it is good to see that full capacity from the battery. But there is one thing that I noticed. Typically with brand new cells or a brand new battery, you'll see 105% of the advertised capacity, but we didn't quite get that. So I'm interested to see what type of cells they're using on this battery. Now, as for the continuous load test of 200 amps, it ran that without any issues. And for the surge capacity testing, we pulled up to 900 amps on the BMS, and it did not shut off from overcurrent protection. So you're going to want to make sure you have a fuse or a DC breaker installed on the battery for overcurrent protection. And finally, the last test, which was the low temperature charging protection. As the battery was below freezing point, it did not charge. So low temperature charging protection worked properly on the battery. So next, I want to do a teardown of the battery. I've spent the last few minutes getting the lid off the battery, so let's go ahead and take a look inside. Now, lifting up the lid, this is what it looks like on the inside of the battery. So let's briefly go over some of these things before I remove the cells from the inside of the case. They are using this high density foam on top of the cells to protect the top from hitting the top of the battery case. They are using aluminum welded bus bars, and the balance leads are glued and screwed down, which is all good. Right here, you have your main positive terminal of the battery. They are using 3 6-AUG conductors together, which go over to this positive lead going to the outside of the battery case. On the other side of this foam is the negative connection of the battery, which goes into the BMS, which kind of slots in on this side. Now, I've just removed the battery cells from the case, and take a look at this build quality. I am actually pretty impressed for the price. So you have 2 metal plates on each side of the cells, and then they are strapped and compressed with these 2 straps right here. These cells actually have boards in between for expansion and contraction. And then if we move closer, you can see the bus bars here. Like I mentioned earlier, these are aluminum welded bus bars. All of the balance leads are glued and screwed down. And these were all organized inside this foam track along with the main positive conductor. So everything was really nice and organized. Moving over to this side, let's take a closer look at the BMS. Now, in order to learn more about the BMS, I did remove this high density foam that was on top. Now, this is upside down, but it does say Mott Cell 200 amp. It's a 200 amp BMS as advertised. Now, for the conductors, I'm actually impressed here. We have 3 6-AUG wires coming into the BMS, and then we have 3 6-AUG wires going out to the main negative terminal. We do have the balance leads of the battery right here, which are connected and glued in place. That's good to see. And we also have what appears to be a temperature sensor that is glued down here. It's routed up and glued to the top of the battery directly to the cells. So that's good to see as well. Now, we already know that the battery features low temperature charging protection, but what about high temperature cutoff? So I'm going to use this thermal sensor right here. I'm going to apply heat to it, and we'll see if it stops charging the battery. Okay, so there we go. See, it stopped charging. Let's go ahead and cool it off. So as I cool this off, it should lower the temperature of the sensor and it should start charging again. So I'll just give it a few seconds. Oh, there it goes. So the high temperature cutoff works as well. Now, what about the cells they're using for this battery? Well, they appear to be in new condition and all of the QR codes are intact. So I'm going to go ahead and scan these with my app and see what information we can find. Now up on the screen, you're going to see the information I found using my lithium iron phosphate battery app. These appear to be Envision cells and they have a production date near the end of 2023. Now my thought is that these cells sat in a warehouse in a new unused condition for 1.5 to 2 years before they were assembled together into these batteries. Now, does lithium iron phosphate have degradation if it sits idle or not used for a while? Yes, there is a slight degradation. For example, if you have your power station just sitting in your closet or sitting on your shelf not using it, you are degrading those batteries just sitting there. But by how much? Well, I took a picture of one of the QR codes on the battery, and what's interesting is these show as 976 watt-hour cells, meaning that these are actually 305 amp-hour batteries. So the rated capacity is 305 amp-hours. Now, during our capacity test, we pulled a total of 307 amp-hours, or a little bit more than 307. So even though these sat in a warehouse not being used, we still pulled over the full rated capacity of the batteries. Now, I will say, when they're in a new condition, you usually get a little boost in capacity. If these were brand new and this was a 305 amp hour battery, you'd probably see around 313 amp hours, but then that kind of drops down after the battery is cycled a few times. So pretty interesting that even after 1.5 years or 2 years of the battery sitting in a warehouse, they didn't degrade that much. We still pull full rated capacity from these cells. Now, over the last 2 months, I've been testing this battery and I've actually taken it on 2 separate camping trips. Now, my camping setup is super simple. I have a 12-volt fridge, I have a Starlink Mini, I power 12-volt fans, sometimes I have some LED lights, I charge mobile devices, charge flashlight batteries, and basically I attach this type of box, which is just USB ports and some 12-volt connections, to the battery directly, and it's allowed me to power everything that I need to. It's a super simple setup. In fact, when I go on the camping trip, this has so much capacity, I don't even have to think about charging the battery, and I've never had this die on a camping trip. It just allows me to have 3 times the amount of energy than having a 100 amp hour battery, but it doesn't even take up that much more space. So if you have an overlanding setup and you're looking for a longer runtime, or if you have a car camping setup and you're looking for, something similar, I would definitely recommend this battery for a very affordable option to get a massive amount of capacity. Now let me know what you guys think about the Dr. Prepare 300 amp hour compact battery. For anybody that's interested in purchasing the battery or learning more, I will include a link to it down in the video description along with my 10% off discount code. Now, I want to know what you guys use on your camping trips. Do you use a battery like this? Do you use a power station? Make sure you leave a comment down below. Thanks for watching, guys. I will recommend a couple of other videos that you can check out. Please smash the thumbs up button before leaving, and hopefully we'll see you guys in the next video.